Hey guys, this is Ken. In this video, I will introduce you to my project, Visualizing Semantic Similarity Measurements and Their Effectiveness. I will describe the research problem, explain my envisioned approaches, and demonstrate the tool with some demos. You can follow the provided timeline of each section on the screen to navigate to parts of your interests. Let's dive right in. First, I want to talk about why visualizing semantic properties has been a challenge to the NLP community. In 2013, Google published Word2Vec, a technique that transforms words into vectors that we call embeddings. This is soon adopted as one of the most popular paradigm in the community, and it inspired many models that we still use today. However, one of the most appealing benefits of Word2Vec is that many semantic properties are visible through the mathematical relationships between the vectors on a lower dimensional canvas. As we develop more advanced models, those embeddings now lay in a stunning 768-dimensional space and can now represent sentences. As a result, there is no way for us to visualize them directly on a 2D or 3D canvas. In this project, we are interested in the following research question. Is there a way to illustrate a well-performing high-dimensional sentence embedding in a lower dimensional space while maintaining its performance and semantic properties? For the purpose of this project, we will be specifically looking at semantic similarity and related tasks. There seems to be two approaches that could potentially solve this problem. One is to reduce those embeddings to a lower dimensional space using various dimensionality reduction methods. The other is to visualize the mathematical properties directly, which oftentimes are of lower dimensions. I will try to address this question from both approaches. That is, I will attempt to invent a novel dimensionality reduction method and, in the meantime, develop a semantic property visualization tool that enables cross-evaluation. Let's start from dimensionality reductions. There are many existing methods, but they all share the same problem when dealing with sentence embeddings. The low-dimensional vector produced from those methods often no longer preserve their semantic properties. That is, those reduced vectors will no longer work on the task they were evaluated upon, and the visualization developed from those reduced vectors no longer possess the intuitive visual orientation of its semantic properties. To make a more similarity-friendly dimensionality reduction method, I want to draw inspiration from force-directed graphs. I've been looking into a couple papers that discusses the possibility of this idea and exploring my way. But for the interest of time, in this video, I will focus on describing and demoing the next approach. If we just look at the relationship between a pair of embeddings, there are various ways for us to obtain a low-dimensional quantity. The challenge then comes from evaluations. Semantic properties are often intuitively derivable and easily understandable, but it is hard to assess how well such properties are represented. For my visualization tool, the major goal we want to achieve is to enable evaluations of a particular semantic similarity measurement. Since there hasn't been a golden standard on a perfect measurement that captures semantic similarity, we want to at least be able to compare two measurements on how much they agree with each other. Thankfully, I have already developed a demo version of this tool with existing libraries, and I think it speaks more than my words. In the initial design, this visualization tool will produce a diagram like this. In this polar coordinate, two channels, angles and colors, are used for two different similarity measurements. There are three poles with respect to a chosen reference sentence. Semantically identical, represented by 0-degree angle or green. Semantically negated, represented by a 180-degree angle or red. Completely irrelevant, represented by 90-degree angle or yellow. By comparing the channels, we can easily spot disagreements between two measurements. After collecting feedbacks, the new design replaces sentences with colored lines with hoverable display. This allows the user to identify the color pattern and investigate details at ease. Here are a few usage scenarios. Negation is often not handled well by widely used similarity measurements such as cosine. Here we can manually set the negation to be red and see where in the distribution did it land. In this case, the diagram tells us there is a distributional disagreement, as many yellow and orange are mapped to a region that are ideally green. We can also spot a few orange dense regions in which we can look at the sentences in detail and analyze other semantic properties they possess. These demos also revealed some limitations and risks in this project. For example, it is hard to pick specific sentences from big dataset. Or when the measurements themselves are chaotic, the outcome is likely gonna follow. I will try to address those in the next stage of development. And that concludes my update video on the idea of my project and recent progress. Unfortunately, I have to leave many details behind. Please consult me via email if you have additional comments or are interested in the future of this project. Thank you for watching.